All right, this is a lesson video for Unit 6, Lesson 2, where we add, subtract, and multiply with radicals. Now keep in mind these all kind of have some different rules. Now here are the big rules with adding and subtracting with radicals, and they must be followed. Okay, your first step is to simplify all radicals, and that's what we did in Lesson 1. So you have to have that skill down first. Then our second step is to identify the radicals with the same index, okay, and same radicand to make them like terms. Okay, we have to have like terms to combine them. So they both have to be the same index, meaning square roots go with square roots if their radicands match, like the square root of 4 with the square root of 4. Not the square root of 4 with the square root of 6. They're not the same. You can't put them together. Okay, so index and radicand have to be matching to make them like terms. Step 3, for common radicals, we add, subtract coefficients and keep the common radical. Okay, so if you have a matching radicand with the same index, then you treat it like you would like a variable, like 2x plus 3x is 5x. All right, the x doesn't change. So once we get the radicands to match, we do not change them, we only add their coefficients. So let's talk about what all that means. Number 1, 3 square root 27 minus 2 square root 12. Okay, right now we cannot put these together because these radicands 27 and 12 do not match. That's like saying 3x minus 2y. Okay, we can't do that. They're not like terms. But if we simplify their radicals first, maybe we can. So this 27 right here can be broken down. 27 is, what's a perfect square? Okay, use your note card, use your list. I'm not really going to break it down as much on this lesson because it'll take way too much time. But in person we will. 27 is the same thing as 9 times 3. Okay, 9 is a perfect square. So I'm going to take out that square root of 9 is a 3. It multiplies with a 3 that's already out there. 3 times 3 is 9. So now all of this is 9 square root 3. That's what the 3 square root 27 turns into. Now I'm going to simplify 2 square root 12. Okay, now what part of 12 is a perfect square? So this is minus 2 times what? 12 is 4 times 3. 4 is a perfect square. So I can take the square root of 4, it comes out as a 2, and multiplies with the 2 that's already out there. So it's really minus 4 square root 3. Okay, now here's the thing. Because they are both square root 3s, that's the matching index, square roots, and the radicands are 3, we can put these together. But this part, it just stays square root 3. It's 9 minus 4 is 5. It's like saying if I had 9x minus 4x equals 5x. Okay, but think of the x as being the square root of 3. You only change the coefficient, not the radicand, once you get them matching. So number 2, we're dealing with cube roots. Okay, look at all of our indexes are 3, so they all have potential to be like terms. But I have to get their radicands. They're all different, 54 to 16. So I need to simplify them first. Now the smallest ones too, to me that gives me a clue, like, oh, maybe these other ones could be a 2, because 2 can't get any smaller than what it is right now. So I'm like 54 divided by 2 is 27, which is a perfect cube. So I'm thinking of this guy as 3 and then cube root of 27 times 2. The cube root of 27 is 3. So the 3 comes out, it gets multiplied with a 3 that was already there. So now this part is 9 cube root of 2. Okay, this one right here in the middle, okay, 2 cannot ever be a cube root of anything. It's smaller than our lowest other perfect cubes. Okay, we can't reduce that ever. So just understand, if you ever have like a square root of 2, cube root 2, fourth root 2, it's not going to be able to change. So we're just going to bring that down. 2 cube root 2. Now what about this last part? Okay, plus 7 cube root of negative 16. Well, I'm going to think of this 7 and then cube root 16 is not a perfect cube, but if I divide it by 2, I get 8. So I'm going to say it's negative 8 times 2 because we always leave the radicand positive. And the cube root of negative 8 is negative 2. Multiply that to the 7 that's already out there. It was a positive 7 times negative 2. So we have negative 14 cube root 2. Again, these are all like terms now, all of them, because they're all cube root 2's. See, this is the part that makes them like terms. So we just put together their coefficients. 9 minus 2 minus 14. So 7 minus 9 minus 2 is 7. 7 minus 14 is negative 7. And we keep that common radical the same. Cube root positive 2. And that's our answer. So again, you have to kind of get your brain to see, you have to simplify the radicals to get them matching and then treat them like they're variables. Just put together the coefficients. Okay, number 3, we have 7 times the 4th root of 48 minus 2 4th root of 3 and 3 cube root of 72. Now, we can only put together things that have matching indexes. So notice we've got 2 4th roots. Those two have potential to be like terms, but because this is a cube root, it won't go together with them. It's like having 2 x terms and then 1 y term. But regardless of that, we still need to simplify all radicals. So here we go. Okay, so this 4th root of 48, I'm looking at my perfect force note card, and I'm looking, and I know that 16 could probably go into 48, and it does. So I have 7, and then I have the 4th root of 16 times 3 makes 48. And we'll take the 4th root of 16 is 2. That's what comes outside, and 2 times 7 is 14. So this is 14 4th root of 3. Now I need to check this part right here. Minus 2 4th root 3. See how it's already matching what I have? 4th root of 3 right here. And again, you can't 4th root a number like 3. So I'm just bringing it down. So minus 2 4th root 3. Okay, plus we have 3 cube root of 72. Well, 72 is not a perfect cube, but I think I can break it down. So we're going to say 3 cube root of what? 72 is also the same thing as 8 times 9. Now don't be fooled. You can't take the cube root of 9. Okay, it's not a square root. The square root of 9 is 2, but not the cube root. The cube root of 8, though, is 2. So make sure you're paying attention to your list. 2 times the 3 that was there is a positive 6, and that's cube root of 9. Okay, what were the like terms? They were the ones that both had a matching index, 4. So we're going to put together 14 minus 2 is 12. 4th root 3 doesn't change. And then we bring down plus 6 cube root of 9. Okay, these are not like terms because for 2 reasons. They don't have the same index and they don't have the same radicand. Okay, number 4. We have 10 square root 28 plus 3, or plus the cube root of negative 56 minus 4 square root 175. Okay, the 2 that have potential to be like terms are the 2 with no index. They're both square roots. Okay, so those are the only 2 that could eventually be put together. So we're dealing with square roots. So we're going to break down our 28 here. This would be 10 square root of what? What perfect square goes into 28? Well, I know that it's 4 times 7, and 4 is a perfect square. The square root of 4 comes out as a 2. It multiplies to 10 to make 20. And then when we leave the square root of 7 inside. The cube root of negative 56. Okay, we can never leave a negative underneath the radical, but I know that 8 times 7 makes 56. So I'm going to break this apart, or break it down and think of it as negative 8 times 7. And the cube root of negative 8 is negative 2. So this becomes now negative 2 cube root of 7. And then last, we're going to break down our 175. Okay, I know that anything that ends like with 75 is divisible by 25, which is a perfect square. So this is negative 4 square root of 25 times 7. The square root of 25 is 5. So this is minus 5 times 4 is negative 20 square root 7. Now it may be tricky to you. It might seem like they're all like terms that we said at the beginning. The only ones that were like terms potentially were the square roots, right? Because there's a cube root as my index, It's not a like term with square roots, even though the radicands match. So it's two things that make them like terms, radicands and index. So 20 minus 20 actually cancels out to 0, and we're just left with negative 2 cube root of 7. Okay, number 5, we have the square root of 98 x to the 4th y squared minus 3x squared y square root 2. Okay, now we're throwing variables into the mix, but we know how to simplify these. So starting with my first term, 98 is not a perfect square, but x to the 4th and y squared are because we're dividing them by 2 to let them out of the radical. But let's break apart 98. Half of 98 is 49. So if I make my little two houses, I've got 49 and 2. And then y to the 4th and y squared both have even exponents, so they are perfect squares. So I'm just going to put them both in the first house, my perfect house. The square root of 49 is 7, so that's what comes out. X to the 4th, we're going to divide it by 2, and we let out x squared. Y squared, we divide by 2, and we let out 1y. Our remainder was square root 2. Now we bring down the next part, because it already has just a square root 2, which is prime number. We can't simplify it anymore. So minus 3 x squared y square root 2. Now these have to be like terms in a few ways. And this part matches, so that it makes them potentially like terms. But once we add variables, again, it's our same rule that we've always had. They have to be the same variables with the same exact exponents. They both have x squared y, so they are like terms, which means we just put together their coefficients. 7 minus 3 is 4. Everything else stays the same, because that's what we do when we add and subtract like terms. So the answer is 4x squared y square root of 2. Hey, number 6, we have the cube root of negative 40a to the 7th plus 2a squared times 3, not times 3, times the cube root of 135a to the 4th. All right, so we're going to break down this first part. Okay, negative 40 is not a perfect cube, but I'm thinking of a factor of 40 that is, and that would be 8. So we're going to say that. We could write this as the cube root of negative 8. And then in the other house, we're going to put a positive 5 because they multiply to make negative 40. Now 7 does not divide by 3. That's what we have to divide our exponents by to let them out of the house. So if I kick out 1a, I have a to the 6th, which is divisible by 3. So I kicked out 1, and I leave 6 in the first. And I'm going to cube root all of this. The cube root of negative 8 is negative 2. A, we have 6 divided by 3 for 2a squared. And then we bring down our leftover part, cube root of 5a. Now this next part right here says times this. So the 2a squared is going to get multiplied to whatever comes out of this house. So I'm going to put 2a squared times, and then I'm going to make my two cube root houses. 135. Okay, 135. Again, I don't know for sure. Oh, and it is a cube root house. Let's see, 27 times 5 makes 135. Yes, check that on my calculator. 27 times 5. 4 does not divide by 3 for my a's, but if I kick out 1a, I have 3 that we can cube root. So what's coming out of this house right here is the cube root of 27 is 3, and for a we do 3 divided by 3 is 1. So 3a comes out. Because it was multiplied to this 2a squared, we're going to multiply them. So we have plus 2 times 3 is 6, a squared times a is a cubed, and then we have the cube root of 5a still inside. So this one is testing us. Okay, they both have this part matching. They're both the cube root of 5a. Those match, but they are not like terms because look at our exponents. This one has an a squared and this one has an a cubed. Because our variables are not matching, the ones on the outside, they are not like terms, and this is as simplified as we can make our answer. So just have to kind of put together all your old rules that you know about variables and exponents with these new ones about radicals and their variables and exponents in that radicand to make sure we understand like terms. Okay, this next section, now we are multiplying radicals. Now our order of operations is different here. When we are adding and subtracting, we simplify first, and then we add and subtract. When we're multiplying, we do not do that, okay? We simplify the resulting radicals. So I put over here on the side, I would say multiply first, then break apart, or simplify. Okay, that's our rule when we're multiplying. We make it be one radical and then we simplify it in the end. That way it's a lot easier. We're going to use our product rule. Okay, now you can only multiply if they have the same index. So square roots with square roots, cube roots with cube roots, and so on. So number 7, because these are both square roots, I can multiply 27 times 5 is 135. So I rewrite it like this. I don't simplify first. I put it together, multiply first. And then I break it apart all at once. If you don't do that first, you just kind of make a mess. So I'm thinking of what is the square root of 135. What can we break that down to? So this would be the same thing as 9 times 15. 9 is a perfect square. The square root of 9 comes out as a 3. So we're left with this, all just simplifies to 3 square root 15. All right, so multiply underneaths with underneaths, radicands with radicands in other words, and coefficients with coefficients. On number 8, 3 square root 10 times negative 2 square root 18. All right, so here's my radical house. I'm going to show 10 and 18 are both radicands, are both underneath, so they multiply. Okay, 10 times 18 makes 180 underneath. My coefficients, 3 and negative 2, they multiply to make negative 6. And now what we're simplifying is the 180 underneath the radical. So 180, okay, if you're using your perfect squares list, remember your note card, you should have 1, 4, 9, 25, 36, 49, 64, and so on. Okay, the number on that list of perfect squares that divides it evenly into 180 will be 36. So we have negative 6 on the outside, and 180 is 36 times 5. The square root of 36 is 6. It comes out of the house. It multiplies with the negative 6 that was already out there. So this is negative 36 square root 5. Okay, number 9, we have 2 cube roots. So because, again, their indexes have to match, they both have a 3 right here. I'm checking that first. We can do this. So again, match up their like parts. Okay, I have a cube root. And I'm going to do 2 times 5. My 2 outsides make 10. My 2 underneaths, 9 times negative 24, make negative 216. I multiplied first. And now I'm going to break down underneath the radical. This negative 216. Well, 216 is a perfect cube. Okay, and I want to take out the negative with it. So this right here, it's negative 6 that comes out. So we're going to do 10 times negative 6 that came out, and this just all simplifies to be negative 60. Okay, number 10, we have 2 fourth root houses. So we're going to use our perfect force to help us, but again, I had to make sure those matched before I start multiplying. So underneath, I am going to make a fourth root house, and my outsides are negative 3 times negative 1. So that's going to make a positive 3. Underneath, I have 64 times 8, which is 512. So this is 3 times the fourth root of 512. Now 512, if I'm using my perfect force list, okay, the number that comes, that is a factor of 512, is 256. So we have 3, the fourth root of 256 times 2. Okay, the fourth root of 256 will come out as 4. Okay, and then we multiply that 4 times 3, which is 12, and we're left with the fourth root of 2 as the leftover part. Okay, number 11, now we're adding variables. Okay, so the rule is not different because we're multiplying. I make sure the index is the same, but I multiply first, simplify second. So I'm going to make a square root house here. I have a 1 basically here. 1 times 5 means 5 is my outside number. Now underneath, 6 times 8 is 48. but then I have x's and I do my product rule. So 4 and 5 do not multiply to 20, they add. 4 plus 9, that's our product rule, is 9. And then I'm going to simplify what's underneath the radical. So I have 5, and then square root, 48 is, the perfect square factor of 48 is 16. And that was times 3. And then I'm checking my variables, x to the 9th. Okay, we're square rooting, it has to be divisible by 2. So we have to kind of take away 1x, leaving us with 8 that is divisible by 2. And then I square root this first house. So square root of 16 is 4. 8 divided by 2 is also 4. So 4x to the 4th comes out. We multiply it with a 5 that's already on the outside. So that gives us 20 x to the 4th, and that remainder part just comes down, square root of 3x. Okay, number 12, we have two cube root houses. Again, their indexes match, so we can multiply them together. So it'll be under a cube root house to begin with. I have nothing on the outside. It was just 1 times 1, stays 1. Underneath, we have 54 times 5 to make 270. All right, and now my variable, m. We have 8 and 4, and they get added together. That makes 12. Now, 270 is not a perfect cube, but look at that end. I know 27 is, so that would make that 27 times 10. So let's break this apart. 27 in the first house, 10 in the second, because 27 times 10 makes 270. Now, 12, it just has to be divisible by 3, and it is, to root it. So I'm going to put the whole thing, m12, in the first house. Now we cube root this. The cube root of 27 is 3. 12 divided by 3 is 4. So it is 3m to the 4th that comes out. And I leave the cube root of 10 as my remainder part that stays underneath. Number 13. Okay, we have two cube roots that we are multiplying together. So let's see what this all comes out as. I have the cube root of negative 3 times 36 is negative 108. I'm going to put together my a's. I have 7 and 6 make 13 when we add them. That's our product rule. Our b's, 4 and 2 make 6. So I need a perfect cube. That's a factor of 108. And if I'm dividing, I get that 27 and 4. So I'm going to make two cube root houses. And I'm going to say it's negative 27. Again, we always leave the remainder part positive. Now my exponents have to divide by 3. 13 does not divide by 3. So if I kick out 1 from 13, I get 12, which is, so I kicked out 1a, I leave 12 in the first. For b's, 6 is divisible by 3, so the whole thing goes in the first house. Okay, we are cube rooting the first house. The cube root of negative 27 is negative 3. Exponents get divided by 3, so 12 divided by 3 is 4. For b, 6 divided by 3 is 2. So we pulled out negative 3, a to the 4th, b squared, and our remainder was the cube root of 4a. And that's all simplified. Okay, number 14. All right, we have two fourth roots that we're working with. So I'm going to put here a fourth root house. And then I'm going to multiply my outsides first. 2 times 7 is 14. Underneath, we are going to apply our product rule to our variables. We have 2 p's and 3 p's to make p5. For my q's, I have 1 q and 10 q's to make q to the 11th power. So the 14 stays on the outside. I'm going to make two fourth root houses for my variables. 5, okay, remember we're dividing by 4 to let them out. 5 does not divide by 4, but if I take away 1 p, and then I'm left with 4, which is divisible by 4. For a q to the 11th power, okay, 11 doesn't divide by 4, neither does 10 or 9, not till I get to 8. So I'm going to put q to the 8th in the first house, and I had to subtract or take away 3 until I got to that number that was a factor of 4. And then we're going to pull out or divide these exponents by 4. So 14 stays on the outside. For p, we have 4 divided by 4 is 1. For q, 8 divided by 4 is 2. So p, q squared comes out. We leave the fourth root of pq cubed inside. So for this last section of our homework, we have binomial examples. So we're multiplying, like using distributive property and FOIL. So we are going to multiply first still, apply the rule of like they have to have the same index. Now outsides or coefficients multiply with coefficients, and radicands, underneath parts, multiply with underneath parts. And then we simplify and combine like terms and all the good stuff. So on 15, we're going to distribute the square root of 10 to 5 square root 5. So the coefficient here is 1. 1 times 5 is 5. Square root 10 times 5 is 50. So you see I did outsides with outsides as I call them, and underneaths with underneaths. And then we're going to take 10 and square root of 10 and distribute it to 2 square root 2. So we have 1 times negative 2 is negative 2. And then square root of 10 times the 2, those are the underneath parts, they make 20. Now we need to simplify these radicals. Right now they don't match. We have 50 and 20. So I would think of my first one, 5 square root 50. We have 5. 50 is 25 times 2. The square root of 25 is 5. It multiplies with the 5 that was already out there. So it's 25 square root 2. My next radical, 20. Okay, so I'm going to say minus 2. 20 is 4 times 5. So 4 times 5. And then the square root of 4 is 2. And it multiplies with the negative 2 that was already there. So it's minus 4 square root 5. Now, I'm checking, can I simplify and put these together anymore? This is a square root 2, this is a square root 5. Their radicands don't match. That's like saying 25x minus 4y. It doesn't work. So this is as simplified as we can make it. Number 16, we have 2 binomials multiplying, so it's FOIL. So let's see how we do. 8 times 3, those are both regular numbers, 24. 8 times negative square root 10, okay, there is no coefficient, so we're just going to kind of stick them together. This is a minus 8 square root 10. And then we come to our insides, we have negative square root 10 times 3, so that's negative times a positive stays negative, the 3 stays outside. The 10 is the underneath part, just stuck them together. And then negative square root 10 times negative square root 10 is a positive. Square root of 10 times 10 is 100. Okay, now we need to simplify. 10 does not simplify at all. Okay, these are just going to be like terms. But 100, whoop, it disappeared. 100 is a perfect square. The square root of 100 is 10. So this 10 can combine with 24. 24 plus 10 is 34. And then my like terms in the middle, we're going to put negative 8 minus 3 is negative 11, but that has to stay square root 10. Remember, we don't change that radical once we switch to combining like terms, just like we don't for exponents or variables either. Okay, number 17, we're foiling again. So we're going to start with 6 square root 6 and multiply it to the square root of 6. So the 6 is this 6 right here that I'm underlining is the only one on the outside, so it stays the same. And then underneath, 6 times 6 is 36. And I'm just going to go through and multiply everything first, simplify the second. 6 square root 6 times the square root of 2. Again, that 6 is on the outside, but 6 times 2 is 12. Then I come and I pick up negative 6 square root 2 times the square root of 6 is minus 6 square root 12, because we did 2 times 6. And then we have negative 6 times 1 stays negative 6. Then 2 times 2, my 2 radicands make square root 4. Okay, I can see that I have like terms in the middle. They both have the square root of 12. And I'm not even going to worry about simplifying them yet because they are like terms already. 6 and negative 6 make 0, so those just canceled out. But we can do some simplifying on these other parts. Okay, square root of 36 is a perfect square. Square root of 36 is 6. It was being multiplied by 6 on the outside, so all of this becomes 36. Now this part over here, minus 6 square root of 4. 4 is a perfect square. The square root of 4 is 2. That comes out. 2 times negative 6 it's attached to is negative 12. So we're going to say this is 36 minus 12. Both of these are just constants. We can put them together. They make 24. On number 18, remember when we square a binomial, that's telling us how many we have of that term. So this is 4 minus square root 5 times its own self, 4 square root 5, which means we need to FOIL. So 4 times 4 is 16. 4 times negative square root 5 is minus 4 square root 5. Then we have minus the same thing again, 4 square root 5. And then negative square root 5 times negative square root 5 is positive. 5 times 5 is 25. They're both underneath, so we can multiply them. Okay, the square root of 25, that's a perfect square. It's 5. It's a like term to 16. 16 plus 5 is 21. Underneath, okay, we have two like terms. They're both radical 5. So we put together negative 4 and negative 4 make negative 8 square root 5. 5 is a prime number underneath a radical, so it won't simplify anymore. So I am done. Okay, number 19, we're adding variables in it again, just like we have been. Same little trend, but process doesn't change. We have two radicands getting multiplied here. 3 times 12 is 36. And then k times k makes k squared. And we distribute to our next term. We have a negative 2 on the outside. Didn't change. And underneath, 3 times 15 is 45. K times k squared is k cubed. Simplify our radicals before we can combine like terms. 36 and k squared are both perfect squares. Square root of 36 is 6. The square root of k squared is k. Okay, there's nothing left underneath because it was a perfect square. Now this next part, we have minus 2. Now 45 is not a perfect square, neither is k cubed. It's not divisible by 2. So we're going to make two houses. 45 is the same thing as 9 times 5. 9's a perfect square. We have to kick out 1k, and we'll keep 2k's because that's divisible by 2. So the square root of 9k squared is 3k. It multiplies to the negative 2, so that's negative 6k, and then square root 5k stays underneath. Now these are not like terms, even though they have this negative 6k part, okay, they're not like terms. The answer is going to stay because of this 5k that was underneath. It's not a like term to my first term. As much as they match, we cannot put, don't put them together, not like terms. They do not have the same radical. Okay, number 20, last problem. We're going to FOIL with some variables. So we have the square root of x times the square root of x is the square root of x squared. The square root of x times the square root of 2 is a positive square root 2x. And then we have negative square root of 8 times the square root of x. It's a lot of tongue twisting things for me today. Negative minus the square root of 8x. And then the square root of 8 times the square root of 2 is the square root of 16. All right. Now, look at, because we multiplied some things by their own selves, we have some perfect squares. The square root of x squared is x. The square root of 16 is 4, so this is a minus 4. These other parts are not like terms yet. 2x will not change, so I'm going to bring this down. Plus square root 2x. Anytime 2 is underneath a radical, you can't ever break down a 2, guys. It's just never going to happen. Think of this as minus, and then I have 8 can break down. We have a 4, and I'm going to say times 2x. That's like the leftover part. 4 comes out, square root of 4 is 2, so this is minus 2, and then square root 2x. Now we have some like terms here. These are the only like terms that I underlined in yellow because they both have 2x underneath the radical. The coefficient here is 1, so I would say 1 minus 2 is negative 1 square root of 2x. But x and 4, minus 4 can't go together, so they just come on down. We have x and then minus 4, and this is as simple as I could do it. Nothing else was like terms. All right, so with multiplying, you multiply first and then simplify your radicals. When you're adding and subtracting only, simplify your radicals first and then combine your like terms. Good luck.